This is the 10th video in my series on alternating current. In this video, we're going to take even a closer look at phasors, this time more specifically, how to add and subtract them. You will find this topic along with others in my course entitled Basic Fundamentals of AC Circuit Analysis. You can access this and my other courses on my Stan Store at this web address. If two AC voltages at 90 degrees out of phase are added together by being connected in series, their voltage magnitudes do not directly add or subtract as with scalar voltages in DC. Instead, these voltage quantities are complex quantities and must add up in a trigonometric fashion. A 6-volt source at 0 degrees added to an 8-volt source at 90 degrees results in 10 volts at a phase angle of 53.13 degrees. Vectors as well as phasors can be moved around a plane as long as their direction and magnitude are maintained. You add vectors or phasors by placing the tail of one on the head of the other, then connecting the other two head and tail together, just like in the picture. Compared to DC circuit analysis, it is very strange indeed. Note that it is possible to obtain voltmeter indications of 6 and 8 volts respectively across two AC voltage sources, yet only read 10 volts for the total voltage. With AC, two voltages can be aiding or opposing one another to any degree between fully aiding and fully opposing inclusive. Without the use of phasor notation, which is a complex number, it would be very difficult to perform mathematical calculations for AC circuit analysis. In this example, I demonstrated adding two AC voltages together that happen to be separated by a phase angle of 90 degrees, which made the arithmetic fairly easy when we were dealing with phasor quantities in polar notation. However, adding and subtracting of complex numbers is much easier if you're able to convert to and from polar and rectangular notation, because the addition and subtraction of phasors in rectangular notation is very easy, and the multiplication and division of phasors in polar notation is the easiest form. So what you want to do is you want to add using rectangular formats, and you want to multiply using polar formatting. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also, from time to time, be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of the aforementioned type products. It is also a connection to obtain a free copy of my 24-page 3-phase transformer workbook, which will serve as a quick reference and reminder of technical calculations that you may need. This address, of course, is case sensitive. I'll spell it out and make sure that you have it right. Everything up to the first number is lowercase. That is, lowercase https://bit.ly/3, then uppercase U, uppercase G, a lowercase j, uppercase B, uppercase I, and lowercase g. One of those amazing and versatile products is the EcoFlow Delta Pro Ultra. which can be modified to suit any homeowner's needs, operating virtually silent, and when paired with the 𝐃𝐈𝐒𝐂𝐋𝐀 Smart Home Panel 2 is extremely versatile. The 𝐃𝐈𝐒𝐂𝐋𝐀 Home Panel 2 ties any and all of your standby power equipment together and will control them efficiently. It will even control your connection to the utility grid to make sure you're only using the least expensive power, switching to your standby power during those expensive time of use rates. In order to view the full range of 𝐃𝐈𝐒𝐂�'s products and obtain a free copy of my three-phase transformer workbook, check into this web address and simply provide your email address, which will guide you to browse the full extent of their products. There is no cost or commitment for viewing, and by providing your email address, it will allow me to keep you posted on future videos, courses, and 𝐃𝐈𝐒𝐂 products.